In this lecture, we learn about how atmospheric pressure can be measured using a device called barometer. To better understand the principle of a mercury barometer, a device used to measure atmospheric pressure, let us quickly review video 18 that discusses about atmospheric pressure. We have seen that the atmosphere roughly extends to 10.3 km from the surface and it weighs nearly 101 kN per square meter on Earth's surface. The value of atmospheric pressure on the surface of the Earth is approximately 101 kPa. In order to measure this pressure, a barometer can be used. In this lecture we discuss about this device. Consider a container partially filled with mercury where its free surface is open to atmosphere. Consider another tube filled with mercury. Now imagine that the tube-filled mercury is placed on the free surface of the mercury in the container with its closed end vertically up as shown in figure. In this position, mercury in the tube flows down to a height h and remains in this equilibrium position. We know that pressure at point 2 inside the tube is same as point 1 on the free surface, where pressure is atmosphere. Now using the equation derived earlier, we can find pressure at 2 in terms of mercury column height, density and gravity. The reference pressure P1 is vapor pressure of mercury which can be neglected. For such barometric configuration the height of mercury will be 76 centimeters. Finally the atmospheric pressure can be calculated as 101.3 kPa. Now imagine that, if such a barometer uses water as fluid instead of mercury, what would be the height of water column that corresponds to the atmospheric pressure 101 kPa? Using the equation P equals ρ GH, we can calculate the height as 10.3 meters of water. Since such a device is not practical, a heavy fluid such as mercury is normally used as barometric fluid. Thank you for listening.